G'day Trailblazers, my name is Cam, and welcome to episode 4 in our Introduction to SQL in Salesforce Marketing Cloud. In today's lesson, we'll be covering aggregate functions and group by statements in your SQL queries that allow you to aggregate and summarize your data into your data extensions. What we'll be covering today in our aggregate functions and group by functions is a direct follow-on from our lesson number 3, where we covered table joins and data relationships. So if you've not covered that one just yet, I recommend pausing the video and completing lesson 3 first, and then rejoining as we continue our journey with our subscribers in our bookshop. So where we left off on lesson number 3 was with our 2 customers who had not yet responded if they were going to attend our book event. Now, our 2 customers, we tried to find out what their total number of books purchased was to give back to our sales team to help them engage with these customers and invite them to the event. We tried to do this by running a function using our query 2 here, which allowed us to look into those data extensions, returning back our customer information, our event reminder, and of course, some info about their invoices, specifically getting the item count, how many books they'd purchased so far. But we ran into a problem. When we did this, our result was that each had only purchased 1 book, which we found out to be wrong because in fact in their invoices tally, they did have a lot more than just 1 book purchased each. Now I'll show you what's happened here. If we go into our properties for our query number 2, we can see that we have a customer ID set as the primary key for this table. Let me show you what happens when we change how this table is being set up. If we go back into our data extensions and create a brand new data extension, this time creating one based on our query 2 that we've already used, but we're not going to choose the primary key. Instead, we're going to be going in and just making it a normal field. So query 2, we'll go, okay, we'll call this one query 2 and we'll call it B. We'll go next and we're going to untick our primary key field. Now show what happens next. Once we've made this data extension, we'll go back into our Automation Studio and rerun that same query. This time, it means we should allow duplicates to occur on that customer ID. So my syntax is still the same. We get all the same fields. We'll go in and this time I'm going to be choosing an overwrite function onto the query 2B. Let's have a look, 2B, there it is, an overwrite. We'll go next. When we run this function, you'll see why it's important to understand your data structure and when appropriate to use your aggregate and group by functions. Let's go run on query 2 to upload our query 2B data and I'll show you the results. So the automation has just finished. If I jump back into my data extensions, I can refresh my page and have a look at what happens between query 2 and query 2B. Remember that query 2 had our 2 subscribers in it. What happens now? I refresh our page. Oh, all of a sudden there is 8 records, and I'll show you why. When we jump into our data, it's actually joined those tables together and produced a record for each returned record across the invoices table. So what we can see here is for Kathleen Towner and Jennifer King. Obviously, Kathleen Towner had 2 invoice records in the invoice table, while Jennifer King had in fact 6 invoice records. And so in fact the total books purchased for Kathleen Towner was 2 books purchased, and for Jennifer King we've got 3, 4, 7, 11, 12 books purchased. Right. And of course we can't give a data extension, or in fact a list for that matter, to our sales team that looks so messy like this. It's the same data repeated over and over again. We don't need to have the customer ID repeated multiple times, or their surname and first name and so on. We just want this to be aggregated. We just want to receive a sum value or a count value of this column to show what the actual total count of books purchased was to give back to our sales team. So how can we achieve this? Well, we can jump back into our query, back in Automation Studio, and I'll show you the function that we can use. Earlier, we simply joined our functions together using our left joins and inner joins to bring through our 3 tables. But we were using them at a detail level, which means that all the data in each table was being considered and printing out a row for each record found across those 3 tables. What we want to do now is aggregate that data. So when learning SQL, one of the really good reference sites you can use is w3schools.com. You can see here on W3 Schools under the SQL language set, and under the SQL tutorial, I have my SQL count, average, and sum functions. And these are some of those aggregate functions that we talked about earlier. So for today, of course, we do want to use the sum function. We are going to want to sum the total number of items they've purchased across all their invoices. So the sum function is declared by the word sum, and then of course the value to sum inside the brackets. So I can jump back into Automation Studio, jump back into my second query here, and start to modify my SQL. So I want to sum the item count so that I produce the correct count of total books purchased. So to sum all those values, I use the word sum. Within round brackets, I declare the value to sum. Now note that this doesn't have a name as a field just yet. I'm doing a function, a sum function, but I haven't got a name for it, and that's what the as total books purchased will do. It declares a name for that field. If I was trying to sum the attending field, for example, I have to make sure that I use the as function at the end to give the result of that function a name. And that way it can go into the correct column in my data extension. Now there's one thing though. At the moment, we know what we're trying to achieve. We are trying to sum this count here of items. But the SQL doesn't quite understand that yet, and I'll show you what happens. If I go validate syntax, it's going to give me an error. It's going to say, well, hang on, I know you're trying to sum things, but you haven't told me how to sum them. You haven't told me how to aggregate your data. You need to tell me what to do using a group by clause. So let's try and use our group by clause. Now, lucky for us, the group by clause goes at the very end of our SQL query, after the from, after the join tables, and after the where clause as well. So make a new line at the end and go group by. Now we have to tell the SQL, what are we grouping by? Well, we want to sum the item count, but then we're summing it on the unique values before it, the things that are not going to be aggregated, those unique values. And those are going to be the ones we don't want to repeat in our data extension, such as customer ID, first name, surname, email address, attending, and their status. So we can provide the list of fields to group by, to then provide the sum record at the end. Now it is a comma-separated list of fields to provide, so I can quite simply copy these comma-separated values just like this, copy and paste after the group by. So we have the customer ID, first name, surname, email address, attending, and reminder status as fields to group on. I can try to validate my syntax now, and we're looking good. So I'll go down, I'm going to save my query as an override, and I'll go finish. So with that done, let's now jump in and run once our query 2 activity. This time again, updating our query 2b data extension. I'll go run and run. Before that finishes running, I'm going to jump back into our data extension. Remember, this was what we're trying to fix up. We don't want to have all of our 8 rows here for our data. We just want 1 row for each customer and then the sum of their books purchased. If I'd used count for Kathleen Towner, the count would be 2. If I'd used count for Jennifer, the count would be 1, 2, 3, 4, 5, 6 would be the count. So I'm not using count, I'm using sum. I'm going to be adding the values together. 2 plus 1 plus 1 plus 3 plus 4, and so on. With that all done, let's go back into Automation Studio and check out the status of our query. Completed, perfect. So let's go back into our data extension folder. And for our query 2b, we now have 2 records, looking good. Now I think for Kathleen it was 2 books, and for Jennifer I think it was 12. Let's have a look. There we go, looking good. So as you can see, the aggregate function with the group by clause is a really powerful way to group your data together. Now we have talked about the sum function and briefly the count function as well. Let's now go through the actual functions using the W3 Schools documentation. To start with, the count function, as we talked about a second ago, allows you to return the number of rows that match that specified criteria. So jumping back into our data extension, we would have seen 6 invoices for Jennifer and 2 invoices for Kathleen had we used the count function. Back into our documentation, our next one here is the AVG, or average. Now for this one, we again are using an aggregate and it returns the average of all numbers returned. So, for example, if we jump back into our data extension, and we did have 2 invoices with 1 book each, therefore a sum of 2, and the average would be 1, because it's the sum divided by the count. Now in the case of Jennifer King, there was 12 books in total across 6 invoices, so the average would be 2 books per invoice. Back into our documentation, and of course we've already covered sum. Now there's 2 more I'd like to cover before we jump into our next function group. That's the min and the max functions. Now back onto our aggregations, what this means is when you declare certain fields to be grouped by, you You can also specify, in addition to the count, average, and sum, a min or max. That is, what is the lowest or the highest value in the field that you're grouping on. So in the example of the min function, back into our data, the min of the count of the books that were purchased across each invoice for Kathleen is 1. The minimum was 1 book. And for Jennifer, I believe that they also had just 1 book purchased as the minimum number of books per invoice. Looking back on our documentation, there's also a max function, return the largest value of the selected column. Looking back to our data again, for Kathleen, again, there's only 2 invoices with 1 each, so the max value for Kathleen would be 1, while Jennifer King, I believe, had an invoice with 3 books, so the max value would be 3. But let's try this out for ourselves. By jumping back into our data extension and back into our format, let's instead make some brand new fields to test this out for ourselves. So we'll jump in and make some brand new fields. Let's try a count field, again as a number. We'll also try a min invoice or min books field to return the minimum number of books that they purchased. And we'll also return a max books to return the maximum number of books they purchased in a single invoice. So we have our count, we have our total, we have our min and our max, and for good measure, let's put our average in too. Beautiful. There's our new fields. Let's go save fields, and we can jump back into our Automation Studio and back into our query. Let's now add those brand new fields and start to write out our SQL to achieve them. Now, the good news here is we've already got our aggregate function below. We're not adding additional detailed fields into our query, we're adding additional aggregate fields. So I can jump back in, and I should be able to go back into my learning, into my query 2b, and hopefully I find my brand new fields are showing up. So I've got, of course, my count, I've got my min books, I've got my max books, and I've got my average books, my brand new fields. So let's now break these out into some nice formatting. We can add these values in. Now for count, we can use our count function. So back in our documentation, back in our SQL for count, average, and sum, count is done as so. Now the good news for count is we can cheat a little bit, because for count we can specify a field to count, in case there are nulls, but if we are counting the total number of rows in general, we can also use a wildcard, Shift 8. For now though, just for good practice, we're only going to count the number of items based on their invoices, so I'll place that value in there. We also have to give it a field name, so of course as what? As count. For the min books, we can use our min function, so I might copy this part of our function down, and we'll use the keyword of min for our function. Min as, of course, our min books. For our max books, it'll be the same thing again, this time the max function. And then for average books, once again, using our average function. All right, there we are. So we now have our brand new aggregates all built in. And again, we can check our syntax and hopefully no errors because there was nothing new on the detail level added, just aggregate fields. So with that done, we'll scroll down and go next. Let's make sure that my counts were correct. Save our automation and run once our query to activity. So our SQL has just finished, so jumping into our data extension and refresh our records. So for our query 2b, again, still just those 2 rows because we have aggregated those 2 customers together. And now in our records, we should have some brand new columns, and we do. Perfect. So like I counted before, we had 2 books for Kathleen and 6 for Jennifer, sorry. A minimum number of books per purchase of 1 and 1. Max was 1 and 4. My apologies. It looks like Jennifer had 4 books in one invoice, with the average count of books per invoice being 1 and 2 respectively. Just looking back at our SQL function, and anyone who does some SQL might tell you that we're a little bit messy with our code so far. We have declared a number of fields to aggregate, of course, our sum, count, min, max, and average. We also have a whole lot of unique fields here, which are making it a little bit messy when it comes to our group by statement. There's one more really good function we can use, particularly when it comes to our grouping by with our additional joined tables. And that's a little trick which is called using a nested query or a subquery. Now what this means is, having a look at our current selection process from our 3 tables, our customers, event reminder, and invoices, we are currently joining in or selecting from the entire table, returning back all the fields in that table and then applying our where conditions in our group by. However, you don't have to select the entire table. You can write a subquery to just produce a sub-selection of that table to then be joined into the rest of our query. So what we can do is make our query here a little bit neater. What we can do is we can pre-aggregate our invoices table before we join it into the rest of our larger query. And I'll show you how that works. First thing we can do is navigate on the left-hand side to make sure we have all the information we need from that table, from the invoices table. So have a look here, and here's our invoices. Now for our invoices, we know that the customer ID is the unique data that we want to group on. We were trying to get the count and average and sum and so on of the item count, as you can see from this field here. So what we can do is we can replace the entire selection of that table with a nested or a subquery. So what we can do is jump on the side of our table selection here and go in a join and do some round brackets. I'll make some space just so we can see what we're doing. So we are inner joining this table. Well, there's nothing there just yet. Let's add something to it. So this table is going to do what? Well, we're going to select. We're going to select the customer ID from our invoices table. And that's it. And then of course, the name of this inner table, this subquery, we're going to remain as the alias of C. We'll call it C again. So we can bring this line back up, and now this subquery is being called C and joined in on customer ID. Just like that, it's doing that, just like we were doing earlier. But we of course required another field from this table, the invoices table, and that was the item count. So we can't just choose customer ID. I'll show you why. Got it syntax, and it says, well, hang on, where's item count? You haven't given me a field in the C table called item count. So let's bring it in. Customer ID and item count. Now that's syntax. And now just those two fields in the SQL invoices are coming through in my query and not the other ones. Okay, that's pretty handy. But we can make this even more efficient. We can pre-aggregate our data instead. So from our invoices table, since our customer ID is the unique value, we have the item count, sure. We don't want the actual item count, we want the sum, the count, the min, and so on. So we can copy our code from here, our sum, our count, our min, and all the rest, and paste it into this nested query, this subquery. Now we don't want C item count because we're actually inside the C selection already. So we don't have to specify C. So we'll drop those out and just select the item count, the sum, the count, the min, the max, the average, and call them, as appropriate, the total books purchased, count, min, max, and so on. Now, of course, once we try and refresh this, it's going to say, well, hang on, this table here doesn't have a group by statement. You've done some aggregations, but where's the group by? Well, you can go down here, you can say group by. Now, what's the unique field in this table? Well, aggregate, 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 and unique. All right. So group by the customer ID. Now that we've done this, the C table for our inner join here is going to have a whole lot of new fields to return. It's going to have the total books purchased, count, min books, and so on, which means we don't have to go and reprocess those values up here. We can just select them exactly as they're coming through from this C table. So we can come up to the top here and say C dot total books purchased and C dot count, and so on and so forth, which makes it a much easier function to read and a lot cleaner as well. So we'll keep going through and renaming each of our selected fields. You can see max books, and then finally our item count will be average books. There's our new fields. Now with that done, we're actually no longer aggregating anything, which you can jump back down to the bottom of our query and remove this statement here. Let's try it out. Hey, looking clean, all right. So for an average SQL developer, when you read this, you're pre-processing your data inside a subquery before you join it into the main query, which makes it a lot neater to handle. So let's go next to make sure the results are still the same for us. We'll go overwrite and save, saving our automation and running once our query once more. So our new query is now running, and hopefully it's now complete. Perfect. And we're jumping into our data extension and refresh our query to B. Hopefully again, just those 2 rows, good. And we'll jump into our records and we should see those same counts once again, for our sum, our count, our min, max, and average. And we do 2 and 12, 2 and 6, 1, 1, 1 all the way across, looking good. So let me now show you why the subqueries are so important to understand how they work and how you can make your queries a lot cleaner when you write them. Let's go through one more scenario for our event invitation data. Let's say that our event team has come back to us and said that they're conscious about our 2 subscribers. They want to know what their average saving has been so far with the books they've purchased from the shop. They want to know, sure, we do have the total value of the invoice, but what could the total recommended retail value have been if they purchased the books on sale versus not on sale? Well, for our customer, of course, we can get the sum of our total value, that's easy. But what about the sum of the total value of the total retail price of those books, just in case their actual invoice value was discounted because the book was on sale? Well, for our customer ID through our invoice, of course, we can get to our invoice detail data extension, which gets us our SKU, which allows us to traverse through into our books data extension, which of course has the actual retail price for those books. If we could sum the price of those books against the SKU, against the number of books purchased in that invoice, back against the actual customer, we should get the total maximum retail value of the books they purchased. We can then compare it against the actual total value they had spent so far across their invoices. That's a mouthful, but hopefully this can show you just how powerful these subqueries can be. So let's jump back into Automation Studio and try it out. So the first thing we have to do is jump in and start to add in our brand new tables for our query. So the first thing we have to do, of course, is bring in some brand new joins. At the moment, we don't have all the tables that we need in our query, so let's go back into our learning and find which ones we need. We do, of course, already have the invoices coming through as C. We now need invoice detail. So let's get invoice detail, this one here, and we can join this one in. Now, to make this query easier for ourselves, we can begin to pre-calculate this. So let's go with an inner join, but we're going to do this as a subquery. So we're going to inner join and make some space. We're going to be selecting stuff from our SQL invoice detail. So let's make a nice format here, SQL detail. From that detail, we then want to what? Well, from detail against our SQL books, joining on SKU. We of course are going to need the invoice detail ID though. I think we can trick it by using invoices first. So let's go back into our data and add those ones in. We want our SQL books. So I'll bring this one in here, an inner join, and bring our books in. I think we're also going to want to bring in though that invoice piece. So let's bring in invoice and we'll change our invoice detail into an inner join. So invoices we'll call A, detail we'll call B, and books we'll call C. Now we can reuse the C function inside of this nested query because it won't be published to the exterior query, its parent query. So we can reuse this one inside here. That's okay, it won't conflict with this C declaration above. So we want to select what from invoices? Well, probably our customer ID again. Good place to start. So we'll bring in our A.customer ID to select customer ID from this invoice table here. We then want to bring in our invoice detail on B. Now, how do we join these two together for our inner join? Well, apparently it's the invoice ID. So we can quite simply say on invoice ID. Let's go through to our invoice detail and bring in our invoice ID. So we should be able to join these on b.invoice ID should be equal to a.invoice ID. Nice. Now we can jump into our books. How do we join our invoice detail to our books? Well, it's going to be on SKU. So we can bring SKU across from both those two tables and make that part of our join function. So joining SQL books C on c.SKU will be equal to, where is the other SKU? Invoice detail, which is B. So b.SKU. So now we're joining in all the tables that we need. From our books table, we need what to aggregate? Well, we need that retail price. So we'll jump back into our table here Let's expand our books. We're going to bring in the retail price. We don't just want the actual retail price, we want the sum of the retail price. And we'll call this one what? Well, for good naming convention, let's call this one the sum retail price. Nice and clean. So we now have the customer ID and the sum of the retail price. And that's it. It's as easy as that. We have our customer ID and the retail price to sum up. But we of course do already have a lot of the fields here that we need to achieve that same previous requirement. We wanted also the total of their total value. How much have they spent for real? So we could do the same thing back in this query. We've got the sum of the retail price, of course coming from our C table. We also want the sum of our total value, and that was on our invoice table. So let's get our invoice and total value, just like that. This was coming from our invoices table, which was our A table. So A dot total value. And we want it to be what? Well, again, the sum. So we'll sum our total value as what? Well, again, for naming conventions, let's call this one sum of total value. So now we have all that we need to solve our problem, the total retail price and the total sum value. So let's close this off and call this new inner join on D. I'm going to do inner join D on D dot customer ID is going to be equal to our A dot customer ID for our SQL customers. A dot customer ID. Now what we can do is of course put our two new values into our data extension for our total value and our retail value. So jump back into our data extension and back into our properties. Let's add our new ones in. Now both of these values were Boolean fields, were decimal fields. So decimal 12.2, decimal 12.2. Jumping in and we're going to do scroll down and decimal 12.2. Let me 2, there we are, nullable, and total value was the first one. Second one was the sum of retail price. So jump in, sum of retail price, and decimal 12.2. Done and save. With those two fields coming in, let's now go back into our query and bring them into our actual query, because right now they're just inside the inner join. They're not being brought into our main selection statement. So we have to add those two fields in. So sum of total value, paste, and sum of retail value, paste. Now of course they're coming from which table? Well, we declared our inner join subquery here to be table D. So we'll copy D as our alias, D.sum and D.sum. New field, and of course because these are the same names as the fields in the data extension, there's no need to use the as clause. So we can validate our syntax. Make sure we're looking good so far. No, of course, our group by function. How can we forget our group by function? Back into our D table and we can copy our group by customer ID. On which table, of course, it's our A.customer ID. Very important to declare which one it comes from. Once more, there we are, much better. So let's save our query for our final time. Next and finish. And one last time, we'll save our automation and run query 2. This time bringing back in those two values, the sum of their total invoice purchased so far, and the sum of the actual retail value of all the books they have purchased. So it's running right now. Let's see what comes back. So while the SQL runs, I've jumped in and made a brand new filtered invoice data extension to pick up the invoices for our two subscribers. Taking a quick look at what we've got so far, it looks like we do have our two subscribers with their 6 and 2 invoices in total, with about $54, $55 in one of those invoices and about $440 in the other. So we'll jump back into Automation Studio and check it out, and we should hopefully have it's finished running. So we'll jump back into our query 2b. Let's refresh our data and see what our brand new total value and total retail comes back as. All right, 56 for our sum total value, and oh, 674. So what's gone wrong here? And the same thing for our sum of retail. All of a sudden, apparently we're paying a lot less than our total day was worth. Now what could have gone wrong? And here's one of the big hang-ups when it comes to your nested queries and your aggregations of your data. You have to be very conscious as to how many records you have under each of your tables. Now, because we do know that some of our purchases, for Jennifer King, for example, had multiple invoices and multiple items per invoice, which means the joining activity that we did between each table, between the customer to invoice, invoice to detail, and detail to books, there's a chance of there being multiple invoices or multiple invoice line items against an individual invoice. We do know that Jennifer, our customer, at some times did purchase multiple books, up to 4 books in fact, per invoice, and so that can skew whether our aggregation works. Going back into our SQL then, there is one easy fix. That's to know exactly how our data is structured and to make sure we don't go any deeper than we need to for our aggregations when it comes to our joins. So looking back at our 2 nested queries here, our first join for C and our second join for D, we don't want to be calculating an A, which is at the invoice level, when we're delving 2 more levels deeper in our tables. We don't want to be aggregating that in case we do have a multi-row match later on. So we should take our sum total value here and put it into a much easier and not as deep query, which would be this first inner join here. So I quite simply can take this piece, edit, go into our query, and I can take my sum total value from this inner join and paste it into this inner join, making it taking part in this query instead. Again, we don't need to reference that table. And it's now going to be the sum total value coming from the C table. So up here and C table. We can then close out this function, recheck it, make sure it's all looking okay, and it is. And we can go back and rerun it. Now for those eagle-eyed amongst you, you may have noticed one more problem, which I'll show you in just a second. As we go through and run this one more time, to refresh that incorrect total value, I'll show you one more problem we've run into when it comes to our aggregation of our tables. We can't just trust a single value. Because as we talked about, when it comes to our transactions for our customers in our bookshop, a customer can have multiple invoices. Each invoice can have multiple items. Those items relate to those books. In the case of this one-to-many taking place, it means we can't simply sum the retail or sale price in a one-to-one-to-one-to-one manner, because it may be a one-to-many-to-one or otherwise. So jumping back into our query, we'll see if it's now finished. I think it's about to start off now, but if we go back and refresh our data, hopefully it comes through. And so we'll jump into our 2B query. And hopefully now we find that our sum total value is now 440. It is good. But we haven't fixed our sum retail because all we've done through our aggregation function so far is counted the total value of each book that was purchased. We've not considered the fact that a customer can purchase multiple of the same book in the same invoice. That is one thing we haven't yet covered. So stay tuned as we jump into lesson number 5, this time covering our functions in SQL. So if you're enjoying this SQL series so far, and you'd like to learn some more SQL tips and tricks, then please let me know in the comments below. And don't forget to give the video a big thumbs up. Otherwise, I'll see you on the next episode, and you can subscribe to the channel to make sure you're notified when that next episode comes out.